Okay, a little bit of a change of venue here, but today I'm going to go over some acid-base stuff, all right? And the first thing we have to do is we have to define what an acid and a base are. These are words that are tossed around a lot, but not many people really understand what these words mean. We have three different definitions of what an acid and base are. We have the Arrhenius definition, Bronsted-Lowry definition, and the Lewis definition. All right, now we went over these notes in class, but just to recap, in the Arrhenius definition, he described acids as donating or as having H pluses and bases as having OH minus. Thus, whenever they mix, they make water. It was a good definition, but it didn't quite encapsulate all the behaviors of acids and bases. And so we moved on to this definition by Bronsted. All right. He stated that acids are H plus ion donors and bases are H plus ion acceptors. All right. So whenever there's an acid, there has to be a base. All right. And lastly, we have the Lewis definition of acids, which is an electron pair acceptor for an acid, and a base is an electron pair donor. This can be somewhat of a confusing definition, but you'll see kind of when I do some drawings where we're getting this information from. So here's the idea. We have hydrochloric acid, HCl, plus sodium hydroxide. All right, now both of these are soluble, which means they're electrolytes, so they break up into ions. Hydrochloric acid being an acid breaks up into H plus and Cl minus. I put brackets here just so you can see what's associated with HCl. NaOH, we have Na plus and OH minus. What happens here is the H plus, the hydrochloric acid, then donates that H plus ion over here to the OH minus. Therefore, this is a base, is accepting the H plus. Hydrochloric acid is the acid, donating the H plus. All right. Now, although we're going to be talking about Bronsted definitions, many times bases do have OH minus. So this is going to play a role, especially in the next video when we start talking about pH. All right. So our products here are H2O liquid and dissolved sodium chloride. Okay. So here's some more examples. We have nitric acid and ammonia. And although ammonia does not have OH minus, it does behave like a base because when we put these in water, ammonia will dissolve in water, but it's not an electrolyte. It doesn't break up in anything. Nitric acid separates an H plus and NO3 minus. That H plus is donated to the ammonia. So the ammonia is accepting the H plus, it is behaving like a base. And when we do this, we get ammonium nitrate. But if we go back and look at this, if we do our net ionic equation, what we find is that it's just H plus NH3 gives us NH4 plus. All right. Now I know this might be a little bit confusing, but the whole idea here is that nitric acid is donating its H plus to ammonia, and ammonia is accepting it. That's making it a base. This is where the Bronsted definition is a better definition because if we looked at the Arrhenius definition, we wouldn't really see any acids and bases here. And when we talk about acids and bases, everything is compared to H2O. That is our benchmark. We're comparing everything to that compound. So here in the red, you can see we have water reacting with ammonia, all right? And when we do this, we get ammonium, the ammonium ion, and the hydroxide ion. And I wrote charge here because I want you to take note of what we have here. Over here, water has a charge of 0, ammonia has a charge of 0. So the total charge on the left-hand side is 0. On the right, ammonia has a +1 charge and hydroxide has a -1 charge. If we add that up, we get 0. So the charge balances on both sides. And then if we draw the Lewis structures, here's water, here's ammonia, you can see that this lone pair from ammonia is going to come over here and snag one of these hydrogens. And then the 2 electrons in the covalent bond between hydrogen and oxygen are going to kick off to the oxygen. And so what we end up getting here is OH minus, NH4 plus. You might be asking yourself, Mr. Beck, how am I going to recognize when this occurs? This is something that takes time. If you think about mathematics now, if you're solving 3x equals 6, we can all do that in our head, but you've done it so many times it now becomes automatic and you can recognize that. We're just introducing the idea of acids and bases, so this will take a little bit. Here, acetic acid reacting with water. Acetic acid is going to kick off that H plus. Water is going to use 2 of its electrons here to grab that H plus. The electrons in the covalent bond are going to kick off to the oxygen, and we end up with the acetate ion and the hydronium ion. Once again, you can see the charges balance on the product side, so we're adding up to 0. Here, acetate is stabilized because it's got that great thing we call resonance. all right? So this is a little bit of an introduction to acids and bases. What is important to understand is that when you hear the word acid, it's going to give up an H+, like hydrochloric acid, nitric acid, acetic acid, benzoic acid. Anytime you hear that, it's going to give up an H+, all right?